Hello everyone. Welcome to Global Azure 2025. We are starting, we have the event, we have two streams, one online here where we will have three sessions. We will have Arin in a few minutes and we will talk about how to choose your AI model for your use case. Then we will have a session about A/B testing in Azure. And the third session in this stream will be about GitHub Copilot. Okay, so the other stream is here physical in Gent, Belgium, and unfortunately those other two sessions will not be recorded. Here in Gent, we will talk about two main topics with Stefan Eskens and Ton van Hote. One will be how to approach, how to host multi-tenant applications in Azure Kubernetes Service. And the second session of Ton van Hote will be about generative AI on top of your data at scale using Azure technology. So we will move on with this live stream. Thank you for joining this event, and thank you for to everyone who will watch this event, the recording on YouTube in the coming days. We hope that we are bringing to you very interesting topics that will help you with your journey with Azure and cloud technologies. Okay, so we did that's everything from my side. I hope you will enjoy the sessions. In 2 minutes, I will give the stage to Ari. Let me just go to the next session. Okay, so we are ready to start with the first session. Let me add Arin to the stage. Hey, Harin, how are you?
Hey Massimo, how are you doing?
Doing very good. Here we are starting, making sure that we can start the online stream, making sure that we can welcome the guest here in Ghent. So everything is fine. It's I love the global Azure since years. So thank you so much to you to join this event, and also to everyone that is organizing these great events worldwide. Every component of this global community. Thank to everybody of you.
Yeah, thank you so much for having me.
It's a pleasure. I yeah. So your session is about choosing the right AI model for depending on our use case. Let me add your stage to the stream, and I will say yeah. Good luck with your session, and I will get back at the end of the presentation if there are any questions. Okay.
All right, thank you.
Cheers.
So, welcome everybody who's joined in online today. I really love that this edition of Global Azure at Kent is kind of a hybrid, running two streams in parallel, and I'm really happy to be part of this, and hopefully take you through a journey where at the end of it we are able to say we now know the means and methods on how to choose the right generative AI model based on our needs. So let's get on with the journey. All right. Who am I? I am Arun Roy. I'm lead architect for cloud native and intelligent apps at Gemini. I'm a Microsoft AI MVP, and I also am part of the Global AI Utrecht chapter here in the Netherlands. And yeah, we also run community events. And very recently we did AgentCon. So yes, we are doing a lot with AI from within the community. So what's on the agenda today? Before we start. So we'll start off kind of set the stage with an introduction. Then we'll kind of dive into the types of generative AI models. We'll look into some criteria that helps us to choosing the right model, and we will look at some tools for model evaluation, comparisons, and yes, and then in the end we'll wrap up with a conclusion and of course do some Q&A. So generative AI is everywhere, looking at industries, running innovation, multiplying efficiency. According to Microsoft, I think they say more than 53,000 organizations are using Azure AI services to create and scale AI solutions. And that ranges from automating complex processes to enhancing customer engagement, boosting productivity. Copilot, I think M365 Copilot, almost everybody's using it. ChatGPT in one form or the other, also a productivity booster. We're developing new products, services, and of course Azure AI at the center of it, powering and allowing us to do more with AI. I think we've seen this slide a lot of times, and it's really that's the spectrum of where Azure AI is making an impact. So it's like we said, automation, personal productivity, customer engagement, everything. The most distinct cases being where it's being generally mostly used right now, a lot of automatic content generation, enhancing customer support through AI-driven chatbots, agents coming into the scene is again changing the whole scenario, and of course, a lot of use cases around personalized marketing campaigns and the likes. Now, with natural language processing and machine learning, applications are more and more being able to interact with the more human-like interactions like text. They are able to understand customer queries. They're able to predict user preferences, and all of this put together, we are just getting to a more efficient operations. We're able to improve customer experiences, and of course, we are able to innovate the products and the services that we build and deliver. Now, what what is it for the developers then? Now, Microsoft's AI toolchain is pretty broad. It is empowering developers with uh, flexibility in terms of productivity, from bringing it from going from code to the cloud. And the best part is it is integrating seamlessly with the Microsoft application and tooling stack. So think of the tools we know: Visual Studio, GitHub, Azure as we know it. All of this are part of this toolchain, which is allowing us developers to build, test, and deploy AI solutions in a very seamless fashion. Sorry. Uh, Azure AI Services, Azure Machine Learning, and they are all platforms that we know that helps us create and manage models. And at the same time, there is also responsible AI tooling that also ensures ethical deployment. And this whole ecosystem is what we as developers are using to build diverse applications. So a little bit more into the different tools and services, right? So the first thing from a generative AI perspective, we need the foundational models, which are required to develop and deploy these custom AI solutions. And that is part of the Azure stack, right? So, and then there are the Azure AI services, so which with we are able to integrate other advanced capabilities like vision, speech, language, in addition to all the generative AI capabilities. There is the Azure Machine Learning, so the platform that is used for building, training, and deploying machine learning models, and it supports end-to-end workflows, which allows collaboration between data scientists and developers. And of course, responsible AI, not to be forgotten. So, ethical and responsible AI deployment. Azure enables that through the possibility of responsible AI tooling, which helps us tackle things like biases, for example. So, all of these tools are further brought together by this magic portal called the Azure AI Foundry, which is kind of a platform that can help us go from ideation to deployment. So combining all of these, we and in Azure AI Foundry, we can very easily build new solutions. Now there is a new tool that has been introduced. It's the AI Toolkit for VS Code. It's a Microsoft extension in VS Code, and with this extension, you can also do a lot of experimentation with generative AI models, but locally. So in your VS Code, you can actually now play with in a playground environment, test out generative AI models. You can even run fine tuning and optimizations of your model. And yeah, you can also then deploy your AI application and model to the cloud. And also, so that's kind of the whole set of tooling and services that come together to help us developers with the build. So we said foundation models are at the core of it, right? So in terms of what's available on Azure and Azure AI Foundry today, there is a very comprehensive model catalog that's available. It consists of almost hundreds of foundation and open source models from around the world. We can explore these models, we can test them, we can even get some sample code on how to use these models in our uh, in our uh, in our code. So there are things what is called the model card, which tells us about the capabilities and the limitations that the models have. There is a playground, which we can use to experiment, of course. And there are also other additional capabilities that Microsoft is bringing. For example, the inference API and the SDK, which allows seamless access and integration, which means if we swap a model behind this inference API, we hardly have to make a change to our code. We can seamlessly do that. This also means that in a very familiar and unified UX, we can actually start experimenting with different models. We can, and it's not just limited to text. We can think of multimodality. You can work with even multimodal models with this playground, and all of this still in a very low latency and cost-effective way. So the continuous approach to evaluate the ever-changing model scenario with newer models coming into play, updated models. We moved away from all the textual, and now we are more into the O1 and the other models where we are doing much more than just textual stuff. So all of this, if we are to start with that journey, Azure AI Foundry and with the inference API, it makes this whole journey of model swapping and experimenting so much easier. So what does it look like? So this is the Azure Model Card and Playground. It's a bit of a screenshot, and this is a comprehensive AI toolkit in itself, right? It's a big model catalog. It has over 40 models from over 14,000 providers. Think of providers like Microsoft, OpenAI, Meta, DeepSeek, all of them, all these models. And then Microsoft is very fast in bringing some of the newer models always up to date. And yeah, we can also, of course, look at their capabilities. We can test them. We can do some task-centric exploration, if you'd say, in a friendly playground. And with agents nowadays, you can even create agents within the AI Foundry. But this requires an Azure subscription. We don't always have that available, and we don't want to also always have a lot of cost associated. So what's another alternative? Another alternative today available is the GitHub Model Card and Playground, or a list of models that GitHub makes available to us. And this is free access to AI models for anyone with a GitHub account. So we have a very similar experience to what we've seen with the Azure AI Foundry. It has also models from different providers, so you can very easily start experimenting, but all for free. You have some limits, of course, but all you need to get started today is just a GitHub account. And there is integration with code spaces, so you can very easily set up stuff. You can do local use of existing code, and you can also switch between model providers because the Azure AI Inference API is also supported with GitHub models, which we will see later on in our demos. So it's about choosing models also means that it is about being able to compare models. We will compare two language models. One is the GPT 3.5 and one is GPT-4. Now, for GPT-4, what we do is we are asking it to generate a prompt for a hyper-realistic portrait of a pirate in this case. It's the same prompt we feed to two models. So what we would see is GPT-4 generates a very detailed prompt. It describes like a pirate. It has very specific features, very specific, like eye patches, tricorn hat, and gold earring, set against dramatic ocean backdrop, all of that at sunset. And it even gives you very specific details like, okay, what's the camera, what's the lens, and all of that information. The same prompt fed to GPT 3.5 also describes a pirate, but much less specificity. So it kind of mentions, yes, we need a rugged pirate. It has a flowing black beard. He has tattoos. He's standing on the deck of a ship during a storm. But yeah, no camera specifications or anything. Yeah, it kind of says, okay, I need 8K resolution or something. So what's the difference, right, between the two models? There is a difference when it comes to the detail and specificity. We see GPT-4, of course, does better. The complexity of the language model, of course, GPT-4 being a more complex and a more advanced model, allows more richer prompts, and also the tuning. So you see GPT 3.5 was tuned for more conversational tasks, which makes it more verbose, and therefore the output is also very verbose. Now, while both these outputs are pretty impressive, but of course we see the difference. Now, what happens when we take this prompt and take it a step further? What we did here is, and I think we've taken those prompts, those generated prompts, and we fed it into Microsoft Designer, and we say, okay, let's compare the outputs. So based on the verbosity, the amount of details, you also see the difference that comes from the resulting prompt. So you see on the left, the GPT-4, it's very highly detailed. It is exactly taking all those specific details from that prompt, and is much more dramatic. On the right, also a pirate, but you see it's much less refined. The face is kind of pixelated. The overall realism, let's say, is lower. So that this is a very simple demonstration that with the evolution of AI, of course, and with more complex and more advanced models, and with things like visuals, you see the nuances and the complexity of those keep changing, and in between, in this very simple test between two models, we could very easily see how GPT-4 kind of excelled in creating this highly detailed and realistic image over what came out from a GPT 3.5 generated prompt, for example. Now, large language models, LLMs, we've all heard of it, like the whole ChatGPT boom. Everybody was talking LLMs. It's got the total recognition. Almost everybody knows what an LLM is. Everybody's done some kind of super impressive interactions with it, like these image generations, or you've done some other interactions with LLMs to do other stuff, of course. But LLMs eventually are also what requires substantial computing resources, because inferencing for an LLM is quite a compute intensive task. Now, not all purposes, not all organizations, not all use cases need or should use that level of power. And this is where the new concept of the small language models comes in. So small language models, they offer a solution where we are looking at models that have domain-specific capabilities, but offer greater compute efficiency. For example, Microsoft has introduced a Pi family of SLMs, starting with Phi 3. Now we are into Phi 4, and they are also available in different sizes. There is a mini, there is a small, there's medium, and they are also available, of course, through the model catalog on Azure, on GitHub, even on Hugging Face for that matter. And what that means is that with this release, we as consumers of models, we now have more choice when it comes to choosing models over a quality cost spectrum, which means that we can now choose the right model for our needs. Now, when we need more efficient and domain specific models, we can go and choose an SLM over an otherwise a versatile and less contextual LLM, which and of course the whole compute power, the requirement for compute really changes the game. The whole part about where are we going with AI, how much GPUs and do we need, how can we scale out? The game changes a lot the moment you start thinking in terms of SLMs. So what if you compare SLMs and LLMs? So large language models, very crucial in natural language processing, of course. It enables machines to understand and generate human language. So if we take an example, GPT-4, 175 billion parameters, very good at doing complex tasks, can understand context, can handle diverse languages. Of course, with the drawbacks that it requires significant computational resources. It has a high cost of running, and of course, to train an LLM, you require a lot of compute and very long training times. On the other hand, for an SLM, far less parameters. They are less resource intensive and are faster to train. They are ideal and suited for simpler tasks, and most importantly, finding great use when it comes to edge device deployments. Now, because these are smaller and simpler, they may struggle with more nuanced text and diverse languages. Now, so that means there is a trade off, which means when choosing between LLMs and SLMs, it really depends on the specific needs and available resources that are available to us at the moment. So let's jump into a demo where we will look at some of this, and I'm going to quickly check if this is too small for you to put it in the chat, and I will try to zoom in a bit. Or maybe I will just, sorry. All right, I don't hear anything, but I'll just zoom in just for it. So in this case, let's look at a couple of things. In this case, I have a notebook. And what I'm doing, I'm going to use the GitHub models for it. And we're going to run a comparison between a GPT-4o and a Phi-3 Vision model. So one LLM and the other an SLM. I'm going to simply use the inference AI API, and I'm going to use just a GitHub token. So I'm going to use a free model. And what we are going to do, we are going to feed or run based on this source image. What we are going to do is we're going to kind of reverse engineer. We use a multimodal capability to read this image, reinference it, create a Python code to recreate this image and see what comes out of it. So let's let's run our GPT-4o notebook first. So as we can see, we just say, yes, please create a Python code for the image and generate code to use BLT to save the new picture. And we ask it to give it a name, and now it has created the picture. So if we look at it, this is what it has created, and this was the original image. So you see that it was able to, with GPT-4o, very close, very fast, it ran very fast, it could do very close. This was 34.9, it kind of gave 35, but more or less exactly was able to recreate that image in no problem. But this was still an LLM. What happens when we run the same test, but in this case, instead of this, we use a Phi series one, and we use the Phi 3.5 Vision. So let's run this one. You see, ran much faster and kind of did a good job. It's not way too off from what it was, and still was able to do the same job, but with far less resources eventually being consumed, with a more targeted approach, and potentially even faster. So you see, so for something like this, running a comparison like this also gives us an idea on, yes, how does it work? Can we just replace an LLM for an SLM for certain tasks? We definitely can, and that's what we are going to talk about today. Let's take another example, and in this case, we will go and see another way of how we can run a comparison. In this case, what I've done is here is a chainlet application. It has some data that is already fed to it in a RAG way. So there is a vector index with the data fed in. And what we can do here to run some comparisons is run something like this. So what we could do is we say, okay, what is the model we use for, let's say, for routing? So the routing is more like where to send to. We will not look at routing as much, but I need to set it. So I'm going to, let's say, set it to Mistral Small in this case. But from an LLM perspective, let's first look at maybe GPT-4o. If we take that, we set this up, and now I can ask. So it says it can answer questions about Paul Graham, and knowing what information is fed in, I can say, okay, what did Paul Graham do after RICS? And I get back kind of, okay, this is what the answer is. Now to compare so we now have GPT-4o getting us or generating this text and giving it back to us. Well, what happens when we change this? So instead of a 4o, we go back to, for example, the 5.3.5 mini. And if I can change it here in this app runtime, I can go back, put this question in, and in this case, it will be using 5.3.5, and it will be coming. You see, 5.3.5 was able to do it, was a bit more verbose. And if you look here, you actually can also see what was the query used. You can also see the LLM that was used. You see the context information a little bit, a lot of this information. What did it find out for Paul Graham information? Yeah, and then also, so you can also look into this. So you can run also comparisons in different ways when it comes to finding ways on how to do it. You can also run it on a notebook, maybe just have with the inference API, because model switching is so much easier. We could have even combined these two notebooks into one, and eventually maybe do a side-by-side comparison in one notebook of two different models. So different ways in which we can get this done. All right, moving on. Model performance, right? So we saw a bit on the evaluation, and evaluation is not always about also the content that comes out. It's also about model performance, because we also want our applications to be performing. So when assessing the model performance, there are different things available to us. We kind of looked at the manual evaluations, of course, but there are also other things like built-in metrics. So we could use these built-in metrics for quick assessments. Some of them are even you can see certain metrics published when you look at the model catalog on GitHub Models or on the Azure AI Foundry model catalog. We could run our custom evaluation flows. So like what we saw with the Chainlit app, we could do that with notebooks. And there are also evaluation capabilities that come as part of the Azure AI Foundry. So with Azure AI Foundry, we can also measure in our evaluations things like accuracy, relevance, and safety also. So and we could do that for single turn or even complex multi-turn conversations. The idea is eventually that we have to ensure that our models perform optimally against the evaluation criteria we set for our applications. Now, SLMs, one of the ways to think of SLMs or small language models are language models with less than 10 billion parameters are classified as SLMs. And like I said, you can find them on Hugging Face, you can find them on GitHub, Azure AI Foundry, all of those places you can find SLMs. Now, because these models are small, they also open up opportunities to run them on various devices. That means think of AI on the edge. So running AI models on local devices or infrastructure, closer to your data sources, closer to your end users. Think of a manufacturing industry where you can just run an LLM or a SLM, sorry. We're so used to saying LLM, a language model in a device right there on the edge. Of course, that means we can ensure that there is lower latency, we can have reduced bandwidth, but of course also enhance privacy, offline capabilities, all of that becomes possible. And of course, that also means we take off a lot of other things like confidentiality, integrity, and availability that can be done. Now, Copilot PCs, we've been hearing all those Microsoft announcements around Copilot PCs. That is also being backed by the Copilot APIs. And these are typically on device machine learning models that can target, they can also do things like Facilica, they can do text recognition, and are going to be part of a WinApp SDK. And we are looking at even more possible. Microsoft is working on possibilities like also including vector embeddings, RAG, text summarization, and a whole lot within this Copilot runtime. And of course, the traditional one, deployment with AI Foundry in the cloud. Thus, with AI Foundry, we can, of course, use all the models from the catalog. We can even upload our own models. We can configure deployment settings, and then, just do a whole lot of things for running efficient and scalable deployment processes. So small language models just take the breadth of it across so many different possibilities. So what helps us run something like a small language model on the edge? There is something called the ONNX runtime. It's a cross-platform inference engine for machine learning models, has been around for quite some time, but is gaining traction with the whole SLM thing again. And it supports various hardware platforms, including CPUs, GPUs, and even NPUs. And it offers optimizations to improve performance and efficiency. For example, with the ONNX, the Onyx runtime mobile, it's an inference engine that can run on mobile applications or for mobile applications on Android. It can run iOS, React Native, MAUI Xamarin. It can run for applications built on any of these, and it can support hardware accelerators like XLMPACK, CoreML, NAPI, and has support for language bindings like C, C++, Java, Objective-C, and even C#. So all of that is supported. There is also the ONNX Runtime Web, and it's a JavaScript library for ONNX models running them in the browsers. It can support multiple backends like WebGPU, WebNN, and has support for hardware acceleration. And you can integrate this into web applications that you build today with, let's say, frameworks like React.js, or if you're building progressive web apps, it can all be included there. There's this concept of EPs that you see on the screen, and these are what are called the execution providers. An execution provider is kind of the plumbing that allows us to or allows these models to run on different hardware. So with execution provider, for example, QNN from Qualcomm or OpenVINO from Intel and DirectML for Windows, we're able to, Onyx runtime is able to support all the different hardware providers, and the hardware providers are working together to make these execution providers available. A great example is DirectML. It's created by Microsoft and targeted for all the Windows GPUs. And if you target something for DirectML, you can actually target any GPU on Windows. You build it once, and you can target any device that's running Windows, be it running any kind of GPU. You have to build it once, and you can run it anytime. So Onyx Runtime actually also allows us to switch between processor types with very minimal code changes, because and you can really very easily recompile something for different platforms, because in the end, it's all about those execution providers and the optimization techniques that we will be using. So you can eventually also think of CPU optimized, let's say, models, targeting using the OpenVINO execution provider, targeting an Intel GPU or a QNN with a Qualcomm GPU. So all of those possibilities open up. Which brings us to the Microsoft Developer Hybrid Loop. on how can you run these optimizations. And at the core of this is a project called Project Olive from Microsoft. It's part of the Onyx toolchain, and it allows us to optimize models for specific hardware by adding. We can add a configuration file to our PyTorch, Onyx, or other models, and what it will do is generates a package with some sample code and optimized models, so we can even test it out. And it based on your configuration, it has the right execution provider, the Onyx runtime libraries, and everything that we can very easily port into our app and start building them. So yeah, to look at, and if you're using the Visual Studio AI Toolkit, Olive comes built into it. So a lot of the boilerplate that you have to otherwise do with setting up Olive and optimizing or fine-tuning your models, today you can even do it right from Visual Studio Code through the AI Toolkit extension, just by doing some drop downs and some configuration. So let's see this in action. What does it mean to run something like this? I will go here and I'm going to start this web application. So this is now going to load a model, and it is going to load the model and cache it in the browser. And I just hope that it doesn't fail now. It takes a bit, yes. And now we are ready. We can look into the to the application here in the moment, and you see in the cache storage, we have the transformers. So you see all the tokenizers and from that are required for Onyx. But you also see here from Onyx, we now have for the Phi 3 Mini 4K Instruct Onyx Web, so targeting the web, the model now that is cached in the browser. So what happens now is, in this, I can say, use this, I can choose a file, and we're going to even look at a RAG implementation. I'm going to take this file. You see, this is the content. It talks about graph RAG, and now it's processing. Of course, it's going to chunk it, index it, vectorize it, and then again, just load all the vectors into memory. So that's what's going on. And all of this, unfortunately, we are on a live stream. I cannot turn off my internet, but in a live demo, generally, this is the point where I actually turn off my internet and I show that this is actually just working in the browser. So this takes a minute. Yes, yeah, my browser is enabled for web GPU and is using the NVIDIA GPU on my laptop at the moment, and that's what it's using it. Yeah, it is. We could even try to do it with a CPU-based one. Probably it will be a little bit more optimized, but I just wanted to use the CPU. So give it a few moments. Sometimes it's fast. Sometimes, depending on what other things I'm running on my PC, it can take a bit longer. Let's see. Yeah. So you also see, so this is how it is broken down. So we see the contents, we see the KBs, we kind of have a thing, but yeah, there are certain things. So we can now ask, tell us about graph RAG, and I can hopefully it reacts. Yeah. And yeah, for once it's loaded and it's there, it's pretty fast, because now you see the time to first token is just 1.9 seconds. It has 71 tokens. Yeah, it generates 90 tokens in 5.2 seconds with 17.32 tokens per second. Pretty fast. It was able to run the query on the in-memory vector space, and it was able to get this answer from this piece of text that we uploaded, and we chunked and put it into the vector memory. And using the LLM, or sorry, the SLM, the optimized model that we have put here yeah, and is cached and running in at this moment from the cache storage in the browser. So that's one. So we also said, oh, we have the option of running with DirectML. So in this case, I will also try to maybe use this. Right. I will first. So this is my project. You see here the ones with the red marks. Those are where the models are. I have local models included in my project. For embedding, I have Phi3. I have Whisper. We're not going to look into Whisper, but we'll see at Phi3. And if I open up my dependencies, I will quickly show what do I have. I have the Microsoft ML Onyx runtime. And I have the runtime GenAI DirectML. Remember, I said DirectML, if you build it once, you can target, so that's using the SDK, and you can target any Windows GPU. So if I take this now, and I'm going to run this, this project. Again, this is running locally. Normal case, I wouldn't need a connection to the internet to run this. Same text, graph rag. What I can do is maybe I can say select this. I can say summarize, and it's using the local Phi3 model, and that is loaded through DirectML, and it's using hardware acceleration, although running locally using the GPU on my computer to run the inferencing, and yes, then it starts giving me the information. So if you want to air gap your solution, don't want to call out to an to a language model that on the internet somewhere outside, you could actually package that as part of your Windows application, targeting the local hardware acceleration in your computer, and still be able to run this kind of applications. Cool, eh? I think it's really cool. So going back to our slides. So it's still about choosing the right models, right? So between large and small language models, of course, there are things to consider. We need to start by identifying the complexity of our task, whether nuanced understanding is needed. Do we need diversity of languages, dialects? What must the model handle? We need to assess what are the available resources. Do we have enough computational power, budget, energy consumption? And I will kind of keep stressing on that. Energy consumption is also important. We should also think of sustainability. Evaluate the deployment environment. What if a solution is better suited for the edge? So look at things like edge device feasibility, the scalability, the flexibility and integration with maybe existing systems. And finally, of course, as we saw with the model performance, we should always also check whether we are able to meet the desired performance. So it's about balancing accuracy and speed to determine what is the real-time processing going to look like. So taking a more holistic approach will ensure that we select the most suitable model for our needs. Now, again, considerations. There are also, when we take all of these, we keep talking about some of the metrics and others. And these can be kind of broadly classified into a couple of things. So you can talk about AI quality, which is kind of paramount in all application practices, because it is the one that will eventually, what is focusing on accuracy, reliability, the robustness, and the scalability of the applications you're building. But then there is also customizability. So the AI apps that we are building, they should also be adaptable. Maybe we need to allow for fine tuning to be able to meet very specific needs. Then there are features, of course. What are the range of tasks that the application should be able to perform? What kind of integrations does it need to our existing systems? Most times, if you think of use cases, most times you'll come up with use cases where you say, I have an existing application and it would be great if I can put some AI capabilities into it. And that's important. And last but not the least, price. So not do not just think of the ongoing operational cost. Think of initial cost of what it takes to acquire the AI solution and also the ongoing operational cost. Now, the other thing that comes with cost is, of course, the latency. So the response time, it's vital if you're thinking of real-time applications. So the strive should be for a cost efficiency that balances cost with performance benefits. So again, a lot of things to consider, a lot of trade-offs, and it's again finding the right balance is what is the key to choosing the right model. Now, Azure AI, the Azure AI platform supports the entire development process, as we saw. So we can with Azure Machine Learning Studios, we can create and deploy models. We can even use AI Foundry to bring in our own models. We can use models from the shelf, and yeah. So the typical phases that you go through to build that experiences. You start with discovering. So you start with the model catalog. You find the best foundational model that fits your task and domain at that point of time. And yeah, you with the model catalog, of course, everything is available at your fingertips. So you don't have to really go out and search for models from various sources. It's all there. We can take those models. You can start kind of fine tuning them if you have very specific needs, or and then also, fine-tuning means you don't have to always deal with the challenges that comes with large-scale model training. So we can take one of those foundational models and we can start fine-tuning them. Evaluation is part of Azure AI Foundry. So we can test the suitability, the accuracy of the models on our own data, and that without having to write code or set up infrastructure. It's part of Azure AI Foundry. And then, of course, we can operationalize these models in our applications and just deploy them. So Azure AI Foundry kind of encompasses this entire journey, and backed by Azure infrastructure, also takes care of our scalability needs, our availability needs, and all the other things that is so essential to have this experience. So one of the things that it comes with the whole purpose of it is also the deployment model. So there is a serverless API and a managed compute option that is available with that you can do through Azure AI Foundry today. Now, with serverless API, of course, you overcome any kind of GPU quota restrictions. You can eliminate GPU provisioning complexity, and you kind of have a very seamless development experience with ready-to-use APIs. Yeah, so there are even options where you're even if one region is not able to respond in a timely manner, you are automatically redirected to another region, and you're kind of always covered. Managed compute is more very specific requirements. So not every model can be supported in a model as a service way. So then the managed compute is more a model as a platform. You have a large collection of large foundation models that you can use. You can manage your own compute, of course, so you have total control on where you're inferencing, where your model and everything is running. And you can also run model performance, and you can also ask for provisional throughput, which ensures that there is always a specific amount of compute available to you at any point of time. Now, foundational models are trained on data at the time of their training, and of course they need to be done. So there are two ways of doing it. There is retrieval augmented generation and fine-tuning. So retrieval augmented generation is pre-trained models, give them external knowledge, which allows them to retrieve more relevant information dynamically. And fine-tune, on the other hand, you train a pre-existing model on a smaller, very task-specific data set and enable it to adapt to particular nuances to have improved accuracy. Now, both are very powerful, of course, but with RAG and prompt engineering, what you do is with RAG integrate the external knowledge bases, so you have additional information. And with prompt engineering, we craft precise and context-rich prompts to guide the model's responses effectively. So together, they give us very specific needs. But if we need any further specificity, very domain specific or very tailored to specific task or domain, of course, we have fine-tuning, which will give us more accurate and context-aware responses and more relevant responses. For the sake of time, I'll just skip the fine-tuning techniques. They are available in the documentation. Model benchmarks, this is what I was talking about. This is what you can also get. You can get performance comparisons. You can get insights into strengths and weaknesses of every model. You can look at their computational efficiencies, and you can also look at what their ethical considerations are and the benchmarks around them. And all of that is available also through the Azure AI Foundry. Again, very important, it's a balancing act, cost, speed, and accuracy. RAG over fine-tuning any day, because you don't have to retrain your model, so you save a lot of compute. And with RAG and good prompting techniques, of course, we can ensure that we always get a proper result. Thus, yes, choosing the right model is crucial for achieving optimal performance. We looked at how we should understand the task requirements, how we should evaluate performance metrics, and we considered deployment environments. Now, we saw some applications. Hopefully that inspires you to build some applications of your own and to look at the different models and their use cases. SLMs over LLMs, hopefully for very specific tasks. And yeah, please do use Azure AI Foundry for all the capabilities that it has. Yeah, I'm excited on what you're going to build next with Azure AI Foundry and the models. Thank you. With that, I would like to thank Global Azure Gent for giving me this opportunity. It was great to be able to present, and I hope you found this content interesting.
Yes, thank you so much, Erin, for this presentation. A very great content, very useful and extremely interesting. I check on the chat. We don't have any question. So again, I will close this first session with again a thank you for your presentation. Thank you for joining this event, and wish you a wonderful evening.
Thank you so much, and yeah, all the best for the rest of the evening. Have a great event, and yeah, let's. I hope I can make it back for your next event again.
Thank you so much. Bye, Arin.
Bye-bye.
So we will go to the next session in a couple of minutes. So let me contact the next speaker, and then we will get back with the stream. And here we are. We are ready for the second session of today. Our next guest is Ivo. Let me add Ivo to the stage. Hey, hello, Ivo. How are you?
Hello, good evening. Yeah, I'm fine.
Great to see you. Okay, Ivo, thank you for joining this event, Global Azure 2025. Your session is about A/B testing, right?
That's correct. Yes.
Okay, I'm all ears. So let me add your video to the stage. Here you are. So
Yeah.
I will left the stage. I wish you a good luck with your session and see you at the end of this talk. Okay,
Thank you very much.
good luck.
Thank you. All right. Good evening, everyone. The session of today is a session is called "The Proof is in the Pudding: A/B Testing in Azure." And first, shortly about me. My name is Ivo Verburg. I'm from the Netherlands. I live in the north of the Netherlands in Friesland. And I'm interested in a lot of subjects in regards to software development. My GitHub and my links are below. I'll also show them at the end of my session. And in my hobbies are sailing. That's why I live in the north. CrossFit, running, scouting, and geocaching. So I like to do a lot of things besides my work. But that's enough for now, because today we're going to talk about something very interesting. And that's something about how to choose what your product should look like and what would be a good addition to your product. Because currently, if we are building software, if we work with in an agile form, we have a product owner. And product owners, they always tend to be the person who knows best what addition would be the best and how that feature would look like. Sometimes, of course, you've got UX designers and maybe some information analysts who advise him. But there's always a product owner, and the product owner has to know exactly what is the best addition. And maybe some of you have the same experience as me, but of course it's always very hard to predict that. So my session is about how to make choices of what value is needed and how that value looks like, how you can improve upon that, how you can make that more efficient. Because I start with product owners who try to predict what the best addition is, but developers, and engineers, they're nearly as bad, because I'm a developer myself, and when I hear about a new technique or a new service in Azure, I always tend to be like, oh yeah, but we should do this, and we should invest time in developing my system this way, or using that subsystem, or a couple of years ago, it was all about, we should build it like microservices, and then we have a stable system or a fast system. But yeah, it's always at some point someone is very convinced, they convince the rest of the team, then a lot of time is invested. And was that initial choice always the best choice? And is that evaluated, and how is that set up? Well, of course, when you work with Agile, and you do development and ops at the same time, you tend to sort of capture that, because when you use DevOps, you first plan, code, build, you go the whole DevOps cycle. And at some point after it's deployed, you're going to monitor the application. But what I see that most of the times, DevOps monitoring is mainly based on the technical part. Does it perform? Aren't there any exceptions? Is everything up and running? Everything connected? And most of the times when customers have complaints, then they come up with something. And the product owner, he has a plan, so he's moving forward. And that's a good thing, of course, if you try to get feedback. But most of the times, the feedback that I see that is collected in the DevOps cycle is mostly technical. And what I actually miss is this cycle. This is a cycle that is used for selling commercial stuff, and that can be food, it can be toys, can be phones, but also web applications. And this cycle is more about assessing the progress. Is it selling? And asking customers, because of course you can have a vision in how your product should look like, and how features are built, and what should be logical steps in a wizard or something, or how the screens would look like. But eventually it's most important to just review it, just check how are customers feeling about your product, how are they using it, if you intended that some screens are made for making a fast addition, or creating a new product or something, or creating a new or adding something to your shopping cart. Is it being used as intended? And are customers also seeing the value, and are they able to find it? Stuff like that is very important. And if you go to product development, if you view it from this perspective, you could maybe get a better feeling and view of what change or what addition would be most valuable for what your current customers are looking for, but also what potential customers are looking for. Because what software mostly look like is something like this. It's I try to find some metrics, some findings on how much of a general product is used, because I once read that almost more than half of general software, web applications, but also desktop applications, things on the phone, more than half of the features that are built aren't being used. And that's because we tend to feel that if you make a product, a web application, a desktop application, you need to fill it with a lot of features because that's what customers need. And if you do that, in a correct way, you'll end up with something like the Swiss Army knife, a lot of special features all packed together into one application. But does that really create the application, or is it the product that customers are finding and that they like? Because most of the times customers actually like simplicity and clarity about what they can or can't use, instead of adding a lot of features and customizations and stuff. And because we're just pushing features, just adding more and more and more, we're actually spending a lot of money on it, because all the development work on creating new features that aren't used, just costs a lot of money. And because of that, if you're selling a software to customers that need to pay for the usage, if you really want to get a good return of investment, maybe it will cost them a lot of money each month. And because of that, you're missing customers, because they're saying, what? I'm not going to pay 50 or 100 euros a month to use this product. And you're like, yeah, but I need at least that many customers paying that, because otherwise, I'm going to go broke, and then there is no product. So we have to look for a smarter, better way of measuring what sort of additions and changes are needed to really fill the customer's need. And in my opinion, that would look more like viewing product development more like experimentation, like a science-based experimentation, like how they do it on this picture. So just try something out and measure it. Is this the expected outcome? What can we change to come more to the expected outcome? And of course, when you view it from a very scientific way, that would mean that you're gonna do it hypothesis-based. And hypothesis-based means that you form an hypothesis, you're gonna validate the hypothesis, and you're gonna check, well, I'm looking for this result, and are we going to get this result? And if that result is correct, if the hypothesis is correct, and and you can view this like a change in a screen, so customers can do something faster, or maybe place a button on another part of the screen, or make it look bigger, or send them an extra notification like, hey, did you think of this, or whatever. If the idea is customers will, because of this, will sell more, use a feature more often, customers will run through a certain process faster, or more customers will use this, stuff like this, that can be an hypothesis, and you can test that. And then just test it for a certain amount of time, and then say, well, okay, my hypothesis was true, and then just continue, or my hypothesis was false, and then you have to look at the learnings and see what the next experiment would be. And how would such a thing look like? Because currently, when we're working in an agile way, then most of the times a new feature or a change is formed in a user story. And the user story has a certain setup to make sure that everyone who looks at it knows for whom or what role we're going to make this change. And the outcome, the expected outcome, is very clear. And the expected change is quite clear. So in this example, we're looking at creating an appointment. And it could be that the product owner of a web application sees that customers aren't making a lot of appointments via the system. And his idea is that maybe it's because a lot of fields are required. And because of that, customers aren't using it that often, because if you start using it, you have to fill in all the required fields. So he's saying, well, I want a new one-field dialog to create an appointment, so I can create an appointment faster. And this sounds very logical. I mean, if you get this as a developer, you're like, oh yeah, okay, easy. Let's create a new screen, only one field, and faster. I guess the users will be able to do it faster because there's only one field instead of 6 required or 10 required fields or whatever. But still, it's not precise enough, in my opinion. And what I found when I was reading something about better development is hypothesis-driven development. And the setup is a little bit different than user stories. Because, well, the setup starts with we believe in, and then the capability will result in, and then a specific outcome. And that outcome has to be measured. So we will have confidence to proceed when we see a measurable sign. And it means that it's all very data-driven. So it's not like, I think it's faster, people are complaining less, I think. But you really are saying, okay, I think this change should be in production, or should be really pushed through or fully developed when we have tested it, and the outcome of the tests will look this way. And hypothesis-driven development, if you apply it to the previous user story, it will look like this. And we believe that a one-field dialog to create an appointment will result in more satisfied users because they can create appointments faster. And then the most important part of this is what is the measurement, how to measure when this is successful. And in this, I'm just saying something here, like we see a minimal average of 25% decrease in time that the user needs to create an appointment, and a minimal increase of 10% of created appointments. So we're expecting people to be able to create appointments faster, And because of that, we're also expecting that more appointments will be created. And that's something you can measure. And A/B testing is just the way to do this. So A/B testing and hypothesis-driven development is just the combination. That's why I thought of this story, this talk. But yeah, how are we going to measure it? Because, yeah, my example that I just gave has to do with the speed of filling something in. You can measure that. And my demo, I'm going to dive into that, and everyone watching this can experiment on it, and then we'll see the outcome. But of course, not everything can be measured this way. I mean, if we're talking about a new feature, then it's hard to compare a non-existing feature versus a feature. And sometimes you have to compare two features against each other. And then it's hard to really say, okay, we've got data stating that currently this is being used this way, and a potential change or feature should be able to increase time or increase the amount or whatever. But especially customer happiness, or things like, well, not current users, will they use the product when this feature is included, or when this change in layout is added? Those things are hard to measure. There are some ways of measuring it. The first thing being customer surveys. That's those annoying things you get also on Azure, saying, well, like, hey, how do you like using this part? And now you're seeing the preview version. Will you fill in a short survey about it? Would you recommend it to your colleagues, to your friends, to your family, stuff like that? I find it very annoying. I rarely fill them in, but because of me investing in this talk, I came to see the value, and I understand why companies use this a lot, because you gotta base it on something, and people tend to complain more than give positive feedbacks. But still, at least you can look at the complaints and you can see, like, okay, we've got 1,000 users, 10 complaints, and from the 1,000 users, 100 said it's just positive and nothing special. Then still you're at a good place, and you can measure such things. So customer surveys do have their place, but getting really good feedback out of them, yeah, it's hard, but it has its place. Another way of measuring the potential value of a change is doing user and or guerrilla testing. User testing could be that maybe you've got a certain group of customers that can use a preview feature. You're saying, well, you've got preview and you can use our new features, and please tell us all about it. That can be just because they have got it enabled, but before people would come to an office and use the new systems. Like, for instance, the new Nintendo Switch, they had the same thing. The new Switch was everywhere. You couldn't bring it home, but then people can just use it. And then, of course, everyone is interested in how did you like it, and how do you like the design in the game, stuff like that. But also guerrilla testing is something that has potential, and that's just sort of walking into a pub or walking into a cafe and just asking someone, hey, I've got something I want to show you. What's your idea? How does it look? Or on the street or wherever. And that's why it's called guerrilla testing. It's just randomly picking someone and asking them about their opinion of your application. Funny, interesting. But there are more ways of measuring, because you could also say, well, if you're thinking of a new screen, you could build a whole screen first and then see how people are reacting. But of course, it costs time. You could also just draw it. A paper prototyping is a very accepted way of especially creating UX designs. Of course, you need someone who is capable of doing such a thing. I mean, when I start drawing, it will never look as good as how my screens will eventually look like. But if you look at this picture, if someone is able to draw this, I think it's very good, smart to at least share your ideas of how the screen will look like, and you can share this with potential customers or customers. I think not via the computer, should be in a meeting or something, or a meeting room, or maybe with some stakeholders. There's also a place for this way of measuring your ID. And of course, real prototyping, so making it almost work in a way. Figma is a very known way of doing this, but you can also make it in a way that it almost behaves as the real application. And and that's why I chose this picture. If you make a prototype with 2 variations, you could directly start asking them, like, okay, I've got 2 variations, just click through it, and then afterwards I'm interested in what your preference is. What do you like more about the one version or the other version? And based on that, you can pick one version and start developing that version. But in my opinion, the best way of really getting a good measurement of your ID is doing it with A/B testing. And A/B testing is just a scientific approach. It's just saying that you should randomly serve version A or B to all your customers, and really just randomly, but make it 50-50. And then just collect data based on that. You could do a customer survey in both versions still, but this definitely works if you are looking for just counting orders, counting stuff, or counting the speeds, looking at performance. This is very good in doing that. And A/B testing, how do you do that? Well, first of all, keep it simple. The whole idea of what I started my talk with is that if you start developing a product and you invest a lot of time in it, you make it a full feature, fully tested, and then let a lot of extra teams look at it, let your quality assurance team look at it. It will cost a lot of time, it will cost a lot of money. And if you want to have it unit tested, 100% coverage, stuff like that, that also costs a lot of money and time. So the basic idea is just to keep it simple. Make it as simple as possible to at least show the ID. So make a minimum viable product. Very, very, very minimum. Just in a way so people at least understand the 2 IDs that you're trying to serve them. Should still work. Doesn't have to be fully fledged, just good enough, minimum viable. And people always tend to say, well, yeah, I'm directly doing it correctly because afterwards we won't get time to really make it a good feature. And then you've got some dirty codes in your system. That's, of course, one of the things you should take care of, that the state is not final. But just make it as simple as possible, and then go split testing. This is a way that I'm going to show you how to do this in Azure. And that just means that, on the picture, you'll see that 25% of all customers get the emails testing branch served, and 75% get the main branch served. But in my opinion, you should just serve everyone 50-50. Because then you can really get a good measurement of the performance and of people's IDs on how how A and B perform and how they look like and what they think of your new feature. So split testing is something I would say is the best way of getting a real randomly assigned to groups testing results. But another way of doing this, and that's more like the preview version, is just using feature flags. You can just assign certain groups of people, certain customers, give them a feature flag that they have the preview features on. Microsoft is very good at doing that. I always use the preview version of Azure, of Word, Microsoft Teams. I just love getting the preview versions, and well, I think they're quite stable because of course you've got the danger that it's breaking, but doing it feature flagged is also a very smart and wise way of doing it. But yeah, those are the two variations. And the thing with A/B testing is, if you've tested it, you came to the conclusion that A or B should be fully developed, then start improving upon it. Because if all's well, you just made something that is the bare minimum of your product. It's not well designed, it's not well coded, but you just at least got feedback that this is the right choice to make and this is the right choice to invest in. So eventually, the whole thing is, it is done in production. And that's always fun, because the biggest con, I'm going to end the demo and this talk with the pros and cons. But the biggest con, of course, in the whole idea of A/B testing is that, well, I'm saying make it minimal. Don't do it fully developed, not fully coverage. But that means that not really, normally you would say, well, this code is not production ready. But yeah, now I'm saying just push code to production that isn't really maybe complete according to your code conventions or to your code coverage conventions. It's not maybe fully tested. Maybe it is just using some hard-coded values or whatever. But the thing is that this way you'll get feedback faster. And that means sort of testing your code in production. But never be too afraid. All right, we're going to the demo. The demo of A/B testing. As I said, it's going to be like the split testing. And what I did, I created an application, very simple Blazor application. I'm going to show something of the code first, and then we're going to see if everyone who's following can help me out with testing it. Because what I have here is a simple Blazor application. And the Blazor application has two ways of creating a reservation. And as the name states, there's a way of making a quick reservation. Well, quick reservation sounds like it's going to be very quick, and that's true. It's only got 3 fields. It starts with a name. And I'm already saying, if everyone who's following, if you're going to test it, if you're going to help me getting some test data, some feedback on my features, please fill in the name so we know eventually who was quickest. It's going to be a small game. And I see that I made a muck instead of make. That's cool. It's the first time I noticed this one, and this is the third time I give this talk. And there's also a complete reservation. And the complete reservation has a lot of fields, some extra validation on the fields. It's going to take more time to fill this one out. And what I did here is, when the screen is initialized, I'm going to use application insights, and I'm going to start tracking the events. And the event has a name, and it means that this is used as a sort of starting point, and it's just gonna gather a lot of information and details about what is being done on this page. And eventually, when submit is pressed, if the form is valid, I'm gonna stop that event. And I'm going to push some extra data, because this is all sent to application insights. And then I'm going to send, if it's validated, I'm going to send the name of the person who completed it. Validated was true and it was valid. But it could also be that it isn't valid. And then I'm going to stop tracking the event. And I'm just going to paste that it's validated, but it wasn't valid. And of course, you also can have the other situation where, we stopped tracking the event because the page was disposed. So the browser was closed, or navigation was started. So people go to another page refresh button, stuff like that. And I'm also going to track that. This means that I can get a lot of information out of how long people are using it, how fast they're using it, and if they're using it, and if they can get to filling in a valid form. And well, the same thing is also done on the complete reservation. You'll see the same code here. And eventually that page is deployed to Azure. So I'm going to show how it looks on Azure. Oh, I left the page open too long, so it has to reauthorize. Yeah, there it is. I've got a web app here. This is my deployment of the application that I just saw. And I'm using or abusing deployment slots for this, because with deployment slots, there's a very cool feature of entering the percentage of traffic that is sent to each slot. And this is made for doing a slow migration from the current version to the newest version. And you can automatically do a swapping and then say every step 10% or something like that. But I'm actually using it for A/B testing, because this way I can just serve the same version of my application to both of them. But I didn't show that in mine. There's it in the nav menu. I've got I'm reading the configuration. I've got a very cool feature flag saying version B, and that's true or false. And depending on that, you're going to be served the complete reservation or the quick reservation. And this, of course, just a very simple configuration thing that I can set up. Because if I go to the environment variables, I can do, configuration. No, I always go to the wrong one if I'm looking for this one. The app settings, extension service. Hey, where? Oh, there. Then setting, and should be here. Otherwise, good story. Oh, yeah. There it is. Oh, of course, I didn't add it in the other one, because if it's not there, then it's just always false. So on my slot B, I said, well, version B is true, meaning that version B is being served by my slot B, and version A is served on my default slot. Well, and because of this, I can get a lot of information. And what we're going to do, I'm going to show you everyone the URL and the QR code for this current website. So please, everyone who's watching this, please go to this URL, and then you'll see a screen saying, well, you're slot A or B, so you know which version you're served. Normally, you won't say that to the users, but now you see which one you're being served, and then you can fill it in the form. Don't forget to fill in your correct name, because then we know out of the data that I'm collecting right now who was fastest, because it's a game. You can see who enters the data fastest. Because I'm going to show you how I can get that data out of Azure via Application Insights. Okay. I should have some entries already now. And what we're going to test is we're going to see. I'm going to show that quickly and then back to the URL. We're going to see if a minimal average of 25% decrease in time is seen between the time of filling in a complete form versus the quick form. Because if it's an average of 25% faster, then it's a good addition. Then it's a good way of doing it. And an increase of 10% of created appointments. Well, we'll just see if the quick reservation is entered more often than the complete reservation. So it's on this URL. Gonna let it hang for a little while longer. And then we're gonna see. Yeah. Just checking how many people there are. I think everyone has entered it now. And now we're gonna check it out. Let's see, you have to go back to, yeah. Yep, first get my queries out. All right, the first thing we're gonna check is how many people did enter this one. And well, I'm gonna check only last 30 minutes because we don't want to see my test results of this afternoon when I checked everything. So let's see how many are filled in. Well, someone, at least one, managed to visit my site. I saw that I had at least 9 YouTube followers. So maybe someone can be as kind as filling a second one. And at least we've got 2 out of the 9 YouTube followers. Maybe Massimo can also fill one in extra. By the way, the cool thing about the slots in Azure is that if you're being served for slot A or B, you are sort of stuck with that slot. And that's, of course, smart because otherwise every request can suddenly turn your application looking like version B. So if you refresh it, Control F5 it, and it will always serve you the same slot version. And that's a pro, in my opinion, if you do A/B testing. But it's also a pro because otherwise, hey, you can't ensure stability of your system. Let's see. Maybe I got one extra. No. Oh, well, that's it then. Doesn't matter, hopefully. Oh, well, it's a shame. And maybe if I pick my test data, then we'll at least have something more. Yeah, then at least we have something more. Okay. Well, as you can see, I've got 3 filled in reservations. The complete reservation has been filled in once, quick reservation twice. And the cool thing is that you can just create bar charts out of stuff like this. So you'll directly see what the average duration is. Well, we're looking for a decrease of 25% of the quick reservation versus the complete reservation. And as you can see, we're definitely there. It's more than half of the time. So that hypothesis has been proven. This is a good and smart way of at least adding that. And we had 2 quick reservations, 1 complete one, meaning that 50% increase of the entered reservations. But of course, there weren't that many entries. So don't know if that's a good metric to really count on. Then we want to know the maxes and the minimums. That's also a very interesting thing, metric if you look at things like this. Like, yeah, you can look at the averages, but are there maybe counts that go really higher or lower? Because those are also interesting to look at. If you're looking at performance or speed, because if someone did it in 1 second, while it's almost impossible to do it 1 second, maybe you should remove those metrics from your eventual conclusion. Then it wasn't a serious one. And eventually, we want to know who did it fastest. And I think the tests were mine. So, that's a shame. Oh well, maybe the last one. Yeah, Agaf. That's the one, at least. Thank you, Aga, for filling it in during this live presentation. I was hoping for maybe a little bit more, but that's okay. But he filled it in 6 seconds, the quick reservation. Sounds logical and true to me. And here you can see the 3 things that are filled in. I just showed you in the code how you're able to push those metrics to application insights. Okay. Well, the thing is, of course, I've got these queries already set up. But if you're doing hypothesis-based development and you're saying, well, yeah, we want to measure it this and this way, you should have these queries present already at the beginning of your work. Because, yeah, if it's not completely clear how it's measured, then the developers can have another view on it, and they're using other ways of validating, at least if they get the correct metrics and if they're being used in the correct way. So always, if you do it this way and you're going to use application insight for it, make sure that you directly create the queries in Application Insight, so you know how it's going to be measured, so there won't be a discussion about that, or you won't be wasting time on this part. Okay, let's get to a conclusion. Well, I just showed you this one, and at least based on the minimal feedback that we had, we could see that at least the minimal average of 25% decrease in time, that was correct. Minimal increase of 10% of created appointments, yeah, that's hard to tell with these findings, but still you should be able to get such metrics out of it when you have a lot of data. You should also say, well, we're going to do this for a full week, Monday morning until Friday afternoon or something. Stuff like that should also be discussed before starting, so it's clear on what time you're doing the A and B testing. Because, yeah, at that point, if you combine it with another A/B testing, it's going to be difficult, and it's also going to be hard to determine what version is being served to whom and how to analyze your metrics. Conclusion. Well, the pros are that you're hopefully are not going to spend a lot of time on a feature and a lot of money on a feature that isn't going to be used, or that eventually isn't the feature that most users are looking for. So hopefully this will save a lot of time and make sure that what you're developing is the thing that we want. And the focus is how is the system used and how can that be improved. And I like that very much. Most of the times you're mainly walking on the idea of product owners or what marketing thinks is the right addition. Well, this is mainly looking at, now let's look at our users, how is it being used? What can we learn from our current users, and how can we improve their experience of the system instead of losing them to maybe another system that sort of is the same. And you're using data-driven arguments. I mean, if you look at prioritization, I always have a lot of discussions with development, with product owner, marketing, everything about priority and how something would look like. Because everyone has their opinion, everyone has their view. And of course, you have to combine those things. But that doesn't mean that the eventual outcome is per se the thing that has most value for the users. It's more like, well, with this group of people that had these views, with 8 developers, 2 marketing, and a product owner, then of course the outcome will be a little bit mingled and mixed and maybe not specifically best for users. So it's data-driven arguments, and those can be used to prioritize the backlog. And I'm saying prioritize, meaning we did an A/B testing, and now we know we have to go for option B. Let's now invest a sprint in making it a full-fledged feature, and then deploy that or something like that. Well, the cons are it's not suitable for all changes. And what I said, the thing is you should be able to measure your desired outcome. And well, you can imagine that there are some features or changes, or if you're building something new, then it's hard to verify your change. You could, of course, always say, well, we're building something new and we're going to check some changes in layouting or placement of buttons or texts or notifications, things like that. However, it will maybe slow you down. So I think it's better if you already have a basic system and you're trying to determine what additions should be smartest. But you can also use it for performance. If you're not sure that a change is best for performance, use an A/B testing to find out. It's hard to test multiple hypotheses at once. That's what I also said. If you have an A/B, that means that for a certain amount of time, you only have version A and B. So you can't say, well, at the same time, I want to test this and this and this against that. Then it's going to be hard. You should be able to continuously deploy to prod, because this means that you have to keep multiple versions in the air. And what I just shown you was with some sort of feature flag serving 2 versions. But But you could also maybe do it in a way that I showed you on the previous screenshot, that you're serving in slot B something from a sub-branch instead of the main branch. But yeah, then it's going to be hard if you don't have a good continuous deployment process set up that's going to allow you to just say, well, yeah, deploy this to that version and that to that. And you have to be able to manage that. The chances of bugs are higher than usual because you're making you should just implement it on a minimal way, in a minimal basis. So that means maybe faster exceptions, and yeah, that's just the way it is. Be sure that you clean up because the chance for dead code are also higher. If version B is the way to go and you don't clean up version A, then that code will linger in your Git repository, and that's not always a good thing. But also, if you're going for a specific choice, everyone in the whole organization has to know that, yeah, okay, this looks right, but it isn't a fully implemented feature. We should still add tests. We should still make the code better maintainable, readable, make it more generic, whatever. All right. That was my conclusion. Then I'll end up with my slides saying something about me with my GitHub, my LinkedIn. Everything that you've just seen, except the Azure part, is on my GitHub. So the application insight queries, and also the source code for the Blazor application is in there. So if you're interested, please go to that site and check my code out and learn something from it. And that would be the end of my session. Massimo, are there any questions or reactions or whatever?
Yeah, I just check on the chat, so we don't have any questions. But this video, you cannot hear me? Does it work right now? That's very weird.
I think, well, my microphone should be still enabled. So let's fill the time because I saw a message. After the session, we'll play a video for a couple of minutes to get you ready. Oh, this is for the next viewer. So the one responding was the next speaker. Well, I'm interested in his talk.
Okay, so you cannot hear me.
And well, I'm not hearing Massimo still, so maybe Massimo, let's just end the session for now, and then you can try and fix that. Oh, I can't hear Massimo. Well, thank you very much for the opportunity of letting me do the talk about A/B testing. Please hit me up on LinkedIn if you have any additional questions or whatever. Check my GitHub. And well, have a good evening and enjoy the rest. Thank you very much.
And here we are back with the last session of today. So there were a little problem with the audio, so I want to thank Ivo for his session and his participation to this event today. Now is the time for our third session. It's time of our friend Ashraf. So let me add Ashraf to the stream. Here you are. Hey Ashraf, how are you doing?
Hi Massimo, hi everyone. I'm fine. What about you?
Very good. The streaming is going on very well here in Ghent, Belgium. We are closing the first session, and then we will go. That was about multi-tenancies and AKS, and then we will talk about building AI on top of your data. But now also there, you just want to tell us how to supercharge our development workflow, right?
Exactly.
With what? GitHub Copilot, right?
Exactly. Exactly.
Okay.
And I want to thank also Ivo and Aaron for the session. I have watched the session and I learned a lot from them. And yeah, good luck for everyone else. And I cannot wait to start my session too.
Okay, I'm gonna add right now your screen and wish you a good luck. And I will see you later at the end of this session.
Thank you,
The stage
Massimo.
is yours. Bye bye.
Bye. Thank you. So, hi everyone and welcome. My name is Ashraf Ben Alaya. I'm an Azure architect, DevOps expert, Microsoft certified trainer, and proudly selected Microsoft MVP since 2024. Whether it is building cloud infra, automating DevOps pipelines, diving into .NET, or talking about games or food, yes, I am here. I'm passionate about simplifying complex tech and sharing that knowledge with the community. Today, we are going to explore how GitHub Copilot can transform the way we code, build, and automate. Whether you are working with Azure, Infra as Code, or day to day with development tasks. So, this session is titled GitHub Copilot Tutorial Automate Coding Azure Infra in minutes, but it not will be only minutes, maybe 1 hour. So, I have broken everything down into bite sized demos. So, I will do a lot of demos instead of presentation. So before we dive in, I would like to give a huge thanks to the Global Azure team for this amazing opportunity to present at such an inspiring global event. And a very special shout out to Massimo for the trust, support, and coordination. All right, let's jump and see what we will see today. So we will start by seeing what is GitHub Copilot in general. We will see some advanced development features. We will try to add some unit tests. We'll start coding, later adding unit tests. And if we have the time, we will see how we can start writing the TDD, writing unit test, and later writing the code. And really, I am excited also to talk today about the Copilot agent mode. We'll see a lot of stuff with the agent mode. And I will end with presenting the model context protocol. And if you have the time, also I will see or I will share how to integrate it with Azure. So let's get started. What is GitHub Copilot and how can we use it? So GitHub Copilot is an AI-powered coding assistant created by GitHub and OpenAI. It helps developers by suggestion code in real time, making the development process faster and more efficient. So it was trained on a massive dataset of public code. It understands a wide range of programming language today. So when we talk about language, we say .NET, Java, PowerShell, TypeScript, and also Terraform, Biceps, everything almost. Copilot today can reduce repetitive tasks, accelerate learning, and act like intelligent pair programmer. So GitHub Copilot today can be integrated with Visual Studio Code, JetBrain, and Azure Data Studio, and a lot of tools today. So we are going to focus on our presentation today on two tools, which are the Visual Studio 2022 actually, and the Visual Studio Code. So I will start doing some demos, and if you have some question, do not hesitate to send me in the chat. So the first demo will go using Visual Studio, and we'll try to generate some code, create some unit tests, and also documentation. And with this, it will be live. So let's get started. I have my Visual Studio ready. So I have it right here. Okay. And the first thing that we are going to do right now is we are going to start by an empty console application. So today, it's true, I'm working with Azure, but I started my career as a full stack.NET, and always I have this passion and special love for the .NET. It's something that is part of me. So let's start by creating an empty .NET console solution. So let's go to Add. Let me zoom in here. New project. And I will go to create a console application. And here I will name it Live Demo Global Azure. Cool. And I will choose the .NET 8.0. I don't need container for now, and I will create the solution. And as you can see, we have our solution here. Let me set it as startup project. So once we run this, it will start first. All right, cool. So as you can see, I only have program.cs right here. And what I'm going to do is I'm going to create a new class, and I will name this class calculate total price. So let me zoom out. I will add a new class. I will name it total price. All right. So I'll put this class as public. And here, let me zoom in. I'm going to paste this comment right here. Let me remove this. Let me do this like that. So this is my comment. I want Copilot to help me to create a decimal calculate total price method that will accept as input a decimal price, a quantity, and tax rate. There is always tax. So if I hit like that, as you can see, Copilot suggests for me this method. And more than that, there is comments. So if I hit tab right now, as you can see, we have to calculate the total price, we have to calculate the tax amount and add the tax amount to the total price. This is awesome. I only wrote one comment, and right now I have the method. But let's test this method if it's really going to work. How can I test this method? So I can write right here, call the calculate. As you can see, automatically Copilot suggests that I call that method that he have created. So I hit tab and I hit enter, and you can see a void method have been generated right here. So let me take this like that. I will comment all this part. I don't need it right here. And I am going to the program.cs right here, and I will call that method. But as you can see here, it doesn't know yet that class. So I will remove this part and I will just call that class. So let me take the name. It is total price. Equal new total price. And also always Copilot is helping me. All right. Like now we are going to test our method that have been created with the price 100, quantity 2, and the tax rate 0.07. Let me zoom out and let's test this method. And here we have the results. As you can see, we have the total price is 214. Let's let's test something else. Let's say the quantity is 6, and let's run this again, and the price is changing. So like that, the method and how to call it, everything was created by Copilot. I almost have done nothing. All right. Let's zoom out right now. I'm going to remove all this part, and I will keep this right here. And right now I'm going to do another test. Let's test something else. Let's say that I want to know which customers are premium and which customers are not. And here I'm going to ask Copilot to use link, or see if he's going to use link queries. So Copilot will understand the common patterns, and these suggestions correctly filter customers and return them as a new list. So let me create a new class right here. And I will name this class premium customers. For the test purpose, it will be public. It's not best practice. And I will take this. I have already prepared my command. And as you can see, this is the method. So it is returning a list of customers that are premium. So I will hit enter. And as you can see, automatically Copilot did understand that he will use a link. I will return the premium customers. So I will hit tab, as you can see. So I just hit tab and the method is right here. So this is because the customer model, it doesn't exist. So what I can do is generate class in a new file. As you can see, there is no more errors. And here I can see the customer, and I will add the property is premium. So here we have our customer. All right. So what I will do again here, Copilot right now is so intelligent, because in previous class I have already told him to call those methods. Right now he's supposed to know that I want to call this get premium customers. So let's see. Call, and I didn't finish writing, and already you can see the customer method. So I will hit tab and I will hit enter. Oh, okay. It happens sometimes. Okay. Maybe I just need to call the get. Let me copy this method. Okay. Sometimes it doesn't work when we are live streaming. And what I will do, if it doesn't work from here, we can go to the GitHub Copilot chat, open chat window. And here, what we can do, we can tell him we are inside the this premium customer, which is the active document. And I will ask him, call the get premium customer method with 2 fake, let's say 3 fake customers. And we will see here what it will generate. So it is thinking. And here, as you can see, it is calling the method. So I can take all this. So let me take this part. And I will go to the program.cs here, as you can see. And here the customer does not contain constructor. All right, I need to create a constructor. And all right, let me just zoom out. What we can do is take this one, and we will update the model. As you can see here, we have the model. So we have the first name, last name, the premium. And if I go back right here, It is calling the premium, and here I will go to the program.cs. I don't need all this. All right. So here, as usual, we need to initiate that class. So I'll just back right here, take that class name, and customers equal, as you can see, Copilot always trying to help me. So here we will check if the customer is premium or not. So we're supposed to get the list of the two customers that are premium right here, which are Joan and Alice. So let's run this and see if it will work or not. And as you can see, we got the result. We have John Doe and Alice Johnson. Both of them are premium customers. So if I go and change, let's say Alice is not premium customer anymore, and see the result. And as you can see, we get only John Doe. And this is amazing. So let's go with another example. Let's say here I'm going to need a new method to check if the email is valid or not. So we will do a method that will check if the address email is valid or not using regex. So let's create here new class, email validation process. All right. Public as usual. And here I will zoom in, and here I will. So I'm asking for a method to validate an email address using regex. I will hit enter, and as you can see, the method is created. So it will return a true or false result. And here I will call the isValid email method, and here I will see if we have suggestion or not. Email at outlook.com. So if we don't see here a suggestion, let me just hit. Let me write another one, call the. All right, sometimes it doesn't work from here, and there is no problem. We will use the chat from here. So always we go back to the GitHub Copilot chat. We can delete the old conversation. And as you can see, we can summarize our code. We can write a unit test from here. We can even ask to fix my code or explain programming concept. But here, it already see that I am in active document, which is email validation process. And I will ask to call isValid email method with this email. So it will be fake email outlook.com. So let me hit the enter and see what will GitHub Copilot suggest for me. All right, so it's generating call, and here we have our method, and here we have the void that will test that email. So let me copy this part and go again to program.cs. I will get rid of all this. And as usual, we need to call that class. So let me email validator process. All right, and here, let me hit, and it will see if the email is valid or not. So this email is valid. So let's try something that's not valid and see if it is correct or not. So as you can see, the result is false. All right, this is actually good. We don't waste much time in creating some complex regex stuff. So here, Copilot have created everything for us. We need to implement that method, and we can right now use it. All right, so maybe right now we will need to do something a bit more complex. So I have received a CSV file. Let me get this CSV file. All right, let's copy this and put it right here. And just I will check one parameter, copy always. All right. So I have this CSV file. I will close everything. All right. So I have this CSV file which contains some fake data about sales and dates. So I'm going to ask Copilot to read this sales data file and create a method to read this content and later call it and give me the results yearly. So for the years that exist here, I want to see the sales results. So what I'm going to do is I'm going here, I'm going to the chat, I will remove this, and I have already prepared my prompt. I will show you my prompt. So in sales data processor, I still didn't create that class. This is good. So I will create a new class. So it can see it active. All right. I'll keep this public for the demo. And go back here. So I will select that class. All right. Create a method to read the sales data as it is, parse it, and calculate yearly sales totals. I will hit enter. And right now, Copilot will analyze that file, and based on that files and the rows and the content, it will create a class in order to read it, and later we'll see how to call it. So this is the class created by GitHub Copilot. So let's take this. Actually, you can insert into a new file or copy it from here. So I will just do like that and zoom out. So here we have our class. All right, cool. So right now I want to use this class. And as you can see here, Copilot even have added explanations. So it added file reading, parsing, year extraction, aggregation, and error handling. So how we can use this? Here we even have the code to call that method. So I will copy this and I will go to program.cs. Here, I will remove this. We don't need it anymore. And I will remove this because I know that the file exists on the same solution. So here we are calling that class sales data processor. We are injecting the CSV file. And here for each row, we are trying to show the total sales for each year. So let's run this. And I hope it works. And this is actually awesome. You can see the result. We have the total sales for the year 2024 and the total sales for 2025. And this is actually pretty awesome. Cool. So let's continue with, I think, the last example with Visual Studio. I'm going to show something a bit complex. So here, we are going to create an API, and we are going to ask for Copilot to generate everything for us. So let me here copy this name. And right now, I'm going to create a new solution or project, sorry, and it will be an API. So it will be an ASP.NET Core API. And I will call this solution, let's say, customer information. Customer information. Okay, so I will use .NET 8.0 and will keep everything. I will use controllers, of course. Create. All right. So the solution is right here. I will put it as startup project. All right, cool. So we have our solution. It is always good to select the files that we are going to use, because like that, Copilot will understand what it will be working on. So let's close this page like that. Okay, I have selected this project that I just have created. Let me close this. And I'm going to here to Copilot, remove this, and I will get my prompt that I have created. All right, I'll show you here. So I am asking Copilot to create an ASP.NET Core API endpoint that can accept JSON with customer information, validate its data, store it in a SQL database using entity framework, and return a success message with the customer ID. All right, so let's hit enter. And here, as you can see, we can use different models. We can use Cloud 3.7 or 3.5, and we can even send a picture from here as an attachment for the example that we want. Or if there is any error, we can send it right here, and Copilot will analyze it. So let me hit enter and see the results. So as you can see, Copilot is thinking right now. And here we have the customer class. Here we have the DB context. And here, this is pretty awesome. Copilot does see that we need to add some packages as a NuGet package to the solution. And here we have the customer validation. Here we have the API endpoint. And here we have the DB context and the connection string. And also, we have the summary. So let's try to implement this so fast and go to another example with another language using Visual Studio Code instead of Visual Studio. So let me implement this quickly. So first thing, we will create a new class. So I will insert this into a new file, and I will select the folder that we are working on. So customer information, and I will hit save. So the file is created. The DB context too, I will save it. I will zoom out just to go quickly. All right. And the validation, this, I will just copy this one. I will select the project. So customer information, and I will hit paste. Let me copy this again. All right, could not find in project. Okay, no problem. We will work with this later. I will select the other files. So we have added the DB context. I will add this like that. And for the controller, I will add it and I will save it inside the controller folder. Okay, later I need also to update this. So add the service for the container. I will go right here and just here I will add this. All right, and this is normal because we have some packages that we have not installed. We'll fix this later. And also we need to update the app settings. So I will copy these parts and I will go to app settings right here and we'll add the connection string. Cool. I will right now install some packages in order to work with the entity framework. So I will add this package right here. And this is the Fluent validation. It is deprecated, but I will use it anyway just for the demo. All right, and I will add some more packages. I just have prepared this right here. So I'll install the entity framework design. Okay, and I will install also the SQL Server entity framework. This one. And I will install also one more package, which is the entity framework tools. Okay, cool. This one is the latest one. And if I go to the program.cs, Let me try to see. Oh, let me remove this. All right, this is gone and this is gone. Okay, let's zoom out and see why this and this must be working if it reads the latest. Okay. Okay. Like that. And I will update the program CS. Just updating a couple of NuGet packages. All right, and let's build the solution. Okay. Always on real life demos, it doesn't work. This is normal. Okay. Let's check out. I will remove this one. I don't need it. Customer controller. All right, API controller. And DB context is right here. All right. All right. This is fixed almost everything. And here I will add this. I think this, I'm missing another extension. I'll see it right here. So let me go back here. We'll see this quickly. If it doesn't work, we'll go to something else. So the tools is installed, the design in the SQL Server. I think I already installed that. Oh, it was not installed. I went a bit quickly. All right. It is right now installed. And it should work. Yeah, everything is correct right now. So what are you going to do right now? We are going to start the migration. So let me, I don't think GitHub Copilot have given me that comment, but earlier in another example have given me that comment. So right here, I will go to the package management. I will clear this. And all right. I will add migration right here. I'll paste. I'll add the migration. All right. Or maybe how to start the entity framework migration if I lost the commands for this project. Let's see if Copilot know. All right, as you can see, .NET Tools install this, and here we will be asked to install the design I have already done, and I will copy this one because this one is responsible for the migration. Let's see if this will work. Can you work directly? Use project. All right, use the project. I will use the project and paste, and I will take the name of this project. All right. Cool. As you can see, the build have started. All right, cool. And let's update the database. All right, again, the project. And it should work. Good. Now this is working. Let's run our solution. We don't need SSL. So right now I need to see a window where I can add user information. All right, so this is the window. Advanced, I will accept the risk, and here API customer, and I will try it. I will add, let's see, the ID one, and the name is Ashraf, and I will execute this right here. And we have an error. As you can see, we have added validation. The email is required. So let me add my email. Execute. And as you can see, we have another error. The phone number must be correct. This is awesome. It's only created by Copilot. So I will add, and let's execute. The phone number must be 10 digits. So 2, 4, 6, 8. Let me remove this. And it seems it's working right now. It is loading. Take a bit of time. And from the example, we will go to another language. So yeah, we have an error here, maybe related to database, and we can investigate this. It is, I think, something related to connection string, I think, on my local computer. Cool. But we already have the API endpoint and everything, and we can even ask Copilot to fix this. All right. So we have seen a lot of examples with Visual Studio. Right now, let's go to Visual Studio Code. And we are going to see a couple of examples with different language. All right. So right here, I'm going to create a new folder and name it VS Code. And here I'm going to launch Visual Studio Code. Okay. Cool. So what are we going to do right now is we are going to ask for some advanced development stuff. So I will create a new file, and this automation.ps1. And here I'm going to ask Copilot for something. In order to ask Copilot for something, we can even use Control+I right here, and this pop-up will hit like that, or we can go and click on this beautiful icon right here, and we can start chatting, adding content, changing the model to ask. And what I'm going to do right now is I'm going right here, and I'm going to ask Copilot for a script to find all the Azure virtual machines in my resource group and output their status, operating system, and size. And the prompt here is very important, and the context, the size, how you write it, how you ask it is very important to get real good data. So let me hit enter. Copilot right now is going to create the PowerShell code for me. You can choose to accept it or ask for another rerun. I will accept this. As you can see, it's asking me to log in and put my resource group name. I already know my resource group name. And here it is even commenting the information. So get all VMs in the specific resource group name. So I will just try to put this like that. I think I'm already connected, and I will hit just enter in order to test this. So let's see the result. All right, as you can see, this is actually completely correct. I have already one virtual machine that is delocated from a month ago, and it is Linux, and it uses this Q standard B1 Alice. So Copilot is so intelligent and can even not only write in .NET, but in PowerShell. So this was the PowerShell example. Right now, let's try something else, and we will go with Terraform. So I think I have already made a folder for Terraform in order to go even faster. So let me be here, and I will launch code from here. All right, so let me delete this, and here I'm going to remove all this, like that. All right, I will hit also remove right here. So here I'm going to ask Copilot to create for me something, not this one. And we can even get a new page right here. I will ask Copilot right now. Let me hit like that. So I will ask Copilot create an Azure app service in West Europe. West Europe. Okay, let's see the response of Copilot. And as you can see, it's creating the resource group. It is creating the service plan. It does know that the app service need an app service plan. This is pretty awesome. All right, let's accept. I already have the provider in another page. And right now, let's hit Terraform in it and see if it is working. Okay, no errors. This is good. And I will see the plan right now. Let me see if there is any error. Let's see the plan. And this is actually very good if you are going to use it for the Amphar as code using Terraform. I already have used this with Terraform. I have already used it with Azure DevOps and even with the workflows. Cool. And here, as you can see, we have the three resources that we are going to create: the resource group, the app service plan, and the app service. We can even go here. Let me remove this. As you can see, this is the current file. And here we can select Azure or GitHub or any other resources. What we can do right here, we can ask explanation, we can ask to create a test, we can ask to debug, and we can ask Azure Learn. But what I want to do actually is I want here to add comments. So I will ask add comment and explanation for this file. All right. Let's see here. So GitHub Copilot is single right now. And as you can see, we can even replace the content. And this is pretty awesome. So here it understands that this is Azure App Service Plan definition. And here, what is the name? What is the pricing, the size? And even, this is really good, the size for someone who doesn't know really Azure, the B1 doesn't know what is its capacity. But for me, I know it. It is one core with 1.75 gigabytes of RAM. So this is the code. And what I can do is click right here, apply to main.tf. And if I click apply like that, as you can see, the content is changing to the new content that I have asked it for. It is still applying, as you can see. And everything is applied. We can even click here to keep it. And this is awesome. Cool. So we have seen right now with Terraform, and we are going to test something else right now. So let me go here. I will not continue with that. And we have seen how to add documentation. Let me go to test something else. All right. I think right now it's time to go and see the agent mode. I don't have a lot of time left, so I will go to the agent mode. So we have seen this. I will share with you the unit test how to do it in my repo, GitHub. I will share that later. But what I really wanted to share is the more context you provide to Copilot, the better the answers you get back. And each time you are going to answer a prompt, you need to make sure to include details and relevant information, be specific about what you are looking for, and break it down to less complex tasks. So small requests, and like that, Copilot will understand how to update, fix, or put your code or add the new code. And if you give really complex stuff, like you less time, and errors may happen. All right, let's go and see what is Agent mode, and I'm really excited about this one. So GitHub Copilot new Agent mode is capable of iterating on its own code, recognizing errors and fixing them automatically. It can suggest terminal commands and ask you to execute them. It also analyzes runtime errors with self-healing capabilities. So as you can see here, next to the menu or the chat button or the ask button, below of it, there is Agent mode. So we are going to select that, and in Agent mode, we are going to create a simple website in Vue.js, and with the voice chat, we are going to ask the Copilot even to upgrade it. So let's go and hit the demo. So I'm going right here, and here I will create a new folder. I will name it Vue.js. Oh, I think there is already a folder, Vue demo. I will launch Visual Studio Code right here. All right. And I will open the chat. And here on this way, I will change this from ask to agent. Cool. In this agent mode, I will ask Copilot to create an app using Vue. So I will send this prompt. So create an app using Vue, use the current directory, and I will hit enter. I will keep the model Claude 3.7 on it in order to create this. So right now, what will happen is Copilot is going to generate everything for me. I don't know how to use Vue. I'm not a front-end developer. I don't know how to use Vue. As you can see here, Copilot always need our help. So we need to apply. So for the first step, it will check if they have npm installed. So it will launch this command. So Copilot did found that I have npm 11.3.0 version installed. Right now, it will be working. He will try to, for example, see the create the Vue.js latest. And he's going to try to create the project architecture, install the model that is needed, and create the default web page for the Vue project. So we are right here, nothing still created, but if you can see here, I need to check the package name, Ashraf, and the select future, I will just hit enter. All right. And as you can see here, we have a couple of files that were created. We have the CRS file, we have the public, and here we have the index page. So it is still creating, as you can see. Let me just zoom out. All right. So I've started creating a new project, and all right, TypeScript, would you like to include any of these? All right. So this is an empty project here. Let me run this project, npm run dev, and see if it is really working. Vite is not running. Okay, we need to, I think, go here. Let me check. npm install. So this time it didn't use the npm install by itself. In earlier demo, GitHub Copilot already added this by itself. Okay, cool. And right now I will run the project. I will go to this URL here. Let me see, where is that? And here we have the default page of Vue. This is really awesome. So you don't have to waste time in order to develop and learn about Vue, but you can just go directly and create your project. All right. One of the greatest and cool things that I'm going to show right now is I'm going to ask Copilot to do something for me, but I will not write anything right here. I will just go here and speak to Copilot. So remove the default content and add a new component for creating a user. All right, I just finished talking. Let me zoom out. And here Copilot by itself started working. So he will right now analyze the project and start editing the component, as you can see here. So I will help you to remove default content and add a new component for creating user in your Vue.js. So here he will start analyzing the files. All right. As you can see, he is reading right now. So it is reading the app.vue. All right. I just have one more demo to do with the MCP, and we will be done for this session. So, all right, I can see the content of your. All right, it is still running in agent mode. Yeah. So it is still analyzing. Sometimes it takes a bit of time. All right. And right now, as you can see, it started already modifying the files. So first, I will create a new user create component. As you can see, it is generating a new component. As you can see, this is a completely new file. So I didn't code anything. I don't know how to use Vue. I just asked it for Copilot via the commands, the vocal commands, to update this project for me. As you can see, it is generating and applying edits. All right. Let's wait a couple of seconds. So here it is inside this file, as you can see, and it is reading. And here it is going to do npm install again. All right, done. So right now it is analyzing the folders and the content of what he have changed in our folders. All right, and now he is asking us to run again. So let's run this and see if it is going to work. So this is the old page. Let's refresh, and this is a pretty awesome user managing system. So here we can enter the data to create, and as you can see, there is a control on this menu. What we can do later here is we can ask Copilot to update to have more modern system, but I will not go through that because I have already taken too much time. So I'm going to go and show you something else, but this is the Azure mode is completely new player, and it's a big changer in the development world. All right, so let me stop this and go to the presentation. All right. And the last thing today that I am going to talk about and present maybe is the model context protocol. So for the last couple of weeks, I have been seeing MCP servers and clients shared everywhere by different people. And with all this buzz, I decided it was time to explore what MCP is and what can be used for, and whether it presents a revolution in AI. So I said, the Model Context Protocol is an open protocol developed by Anthropic that enables large language models, LLMs, to integrate with external data source and tools in a decentralized way. It creates a framework that allows AI tools to communicate with other streamly. So in simple terms, instead of building custom adapters every time we want an AI tool to perform a specific function, like reading from Figma design or managing database or reading GitHub repo, MCP servers can do this for you. So it can call external tools, fetch data, interact with various servers, and access contexts in a manner that generalize across different integration. So in our demo today, what I'm going to do actually, so I'm a bit lazy. I have a repo that I have not updating from a while, and I do not want to code anything or do some research on the internet. So what I'm going to do is I'm going to ask the Azure mode in Copilot with the MCP integration to update a repo for me. So the repo will be this one. I will share the link for the repo. All right. Let me go. So this is my repo right here. And this is my main. And I have updated this repo from 3 weeks ago. All right. This repo present this website. So to represent the acronyms for Microsoft. So if I type LLM, it will give me the large language model. Or if I hit Entra, oh, Entra is missing. So I will add it maybe. API, I can see API, Azure API management. So I will going to ask Copilot to update this for me with the help of the model context protocol. So I have the repo right here. Let me see. Azure mode. No. Hello. So let me see the repo as I will download the repo right here. All right. PowerShell, React, Visual Studio Code. Not here. All right. Let me clone this repo. I can ask Copilot to do that for me, but I will do it by myself. So MCP. Oh, I think I have found it. It's here. All right. So let me open this here and do like that. And we are in the main branch. All right, cool. So first of all, how to see where they are our MCP servers. So if I go right here, and as you can see, we have these MCP list servers, and servers, I have GitHub, which is stopped, and I have Azure. So I will use GitHub this time. I will show you the configuration. So this is my configuration for the MCP. We can add multiple MCP. We can use Docker in order to initialize a server, or you can just run it in the background. So as you can see here, Azure MCP server, and here we have GitHub MCP server. I will run this MCP server for GitHub, which will connect me to my repository through my path token that I have added right here. So if I go to Docker right here, I can see the MCP server developed by GitHub right here. So what I'm going to do, I'm going to ask Copilot an agent mode right here with the help of the MCP server to update this data file. All right. And since it is a big file that contains almost 2,000 row, I will just ask it to add one row, as it will take too much time. So here, I will go here. I will ask Copilot create a new branch. All right. Update the, let's name data.tsx, the data.tsx file. Answer this new row. Let's say I will add Ashraf. I will put my full name, Ashraf Ben Alaya. All right. And create push this branch and push this branch and create a new pull request. All right, can you name it live branch demo? All right. So I'm asking the agent mode with the help of the MCP server that helped me to connect to my repo through my personal token to create a new branch. All right. And this branch, I will ask it to push it to my repo and also create a pull request. I can also ask it to even merge the pull request. How to see the capacity of the server and any server that exists here, we can see through this button, the tools. So this is GitHub Copilot for Azure, for example. And here we have the MCP server for the GitHub Copilot. We can see create a branch, add pull requests, create update files, and all the functionality that exists with the MCP server. So here, as you can see, run create a branch, and we will see here what it will be doing. Sometimes it take a bit longer. All right. So as you can see, it launched new branch. All right. The new branch have been created. Let's see right now. As you can see here, the command have been launched by the GitHub agent mode. Let me just remove this in order for this to go a bit faster. And here, as you can see, it is editing this file. As you can see here, let me just, as you can see, it is analyzing and adding. As you can see, this have been added automatically by the agent mode and the AMCP server. So I didn't do anything manually. This have been added. So it is reading this file in order to understand the structure and the content of this file. And because it contains more than 2000 files, as you can see, it is trying to read this file. So it is applying edit. We are on 25%. And this is actually awesome. So imagine if you had to look for these 2000 or 3000 rows by yourself in order to add or edit or manage stuff. So here, Copilot by itself, it is reading this file, adding the content. And what I want to share, even more than this, 3 weeks earlier, I asked Copilot to add any missing acronyms from Microsoft to this file. I only had at the beginning like 200 or 300 rows. And after this, Copilot by itself, it added all the missing acronyms, and it all have been generated by Copilot. So it went to the internet, looked for all the acronyms that are missing, and have added this to my file. All right, so we are at 60%. So what it shall do right now, after editing this file, it should push this to my repo on GitHub and create a pull request. So we need to see this branch on my repo. So the branch name is live branch demo. So I don't have any branch like that on my repo. If I go back right here, so I only have the add a new acronym, the update, and all this. And most of these branch have been created by the Azure mode and the MCP server. I didn't create anything. I even have an older pull request, but just for the demo, I will show it right here. So I almost finished it. We are on 90%. Copilot still reading the last rows, as you can see here. All right, almost done. 97, 98, 99, and 100. All right. And even more than that, Copilot have detected that there is here some changes. All right. And he even have added some changes right here, like spaces. Yeah, I detected that there is some spaces and tried to fix that. All right, it is working. And as you can see here, he have added this row. So, and git add source. So this is to add the modified file. And after this, I think it will add the commit and the push. All right, it's still working. As you can see right here, it is still working. All right, I have successfully created a new branch called live branch, and I added all the content. Right now, he will run the add Ashraf bin Alaya to anonymous list. So he added the configuration or the commit text. This is pretty awesome. I will check that this text or this commit exists right here. it is still working. As you can see, we have the pause request right here and the cancel button right here if you ever want to cancel or pause. And this is the current file. All right. It is taken a bit longer than usual. All right. I don't know if there is any comments. All right. Let me go here, see the branch, if something have been pushed. Nothing yet. All right. Let's wait a bit. Keep and close this. So it's doing some checks on the background. Sometimes it takes some more time. Let me check if the server is still working or stopped because of memory issue on my machine, because sometimes it happens. So it is still running. I can see it right here. I can see the output right here of the server. Earlier today, when I was testing the server, it is always good to see this output terminal. I was testing, I was running some commands, and it's starting server me for some reason. And I have memory or for my computer was at 98 or 97%, and my computer shut down. So it's good to follow what happens inside the MCP server right here. All right, so let's go back to the terminal. It seems it is a bit here stopping. All right, I will hit done. What I can do is I will go back again to the Azure mode here, and let me check again the server. It is running. So I will say push this new branch. Let me see, git branch to my repo and create a pull request. All right, let's see if it will work faster a bit right now. I have documented, I have done documentation about this on my website. All right, its status. All right, we'll check the remote here. All right, it is pushing this branch. The branch have been pushed. Let's go and see. This is good. Let's see if the branch. So we have 1, 2, 3, 4, 5. We should see 6. And this is the new branch that have been sent right now, live branch demo, as you can see. So let's go back here. And right now it's asking me if I want to create a pull request. So I will say create. And let's see, let's go back to, all right. And the pull requests have been created. Let's go back to the portal. We have already pull request. Let's check here. And here we have the new pull request, the live branch demo pull request. And here we can see this is the request contain the change from the live branch. And in the background, my pipeline started checking this pull request. I can even ask it to merge this pull request directly, but I will not do this because I have already taken too much time. I just wanted to show you on my blog right here. I have shared all the configuration for the MCP server related to GitHub and how to use it and how to do the same as I have done today in this presentation. So let me go back here. Oh, let me just go back to the presentation. And hit like that, swap. Yeah, cool. All right. So I think MCP servers will open the doors and help us in order to integrate the Copilot with many tools, and just be careful when you use it and be careful about the content of each MCP server. All right. So if I have advice I want to share with you, I want to tell you that you need to use GitHub Copilot as a coding assistant, not a crutch. Always try to review and understand its suggestion. So if you are, for example, using GitHub Copilot for PowerShell in order to generate something or automate something, for example, on Azure, I have been really using GitHub Copilot with PowerShell for automation, but you need always to check your code, review what have been created by Copilot, and make sure it's not making mistakes. For example, because if you don't really put the right prompt and the real context and explain to the Copilot, for example, you only need to return the list of the virtual machine, and let's say that per error you have created delete, and or Copilot create delete, and you just hit and you launch your code, you may delete all your virtual machines. So it is really important to always review and understand the suggestion and see what you are doing. All right. Thank you for your attention and participation. Feel free to reach out to me if you have any question. And let's stay connected on the social media. Right here, I have the QR code for my LinkedIn, and this is for my website. Feel free to reach out to me anytime if you have a question about Azure, or if you have a question about GitHub Copilot, the MCP, or the Model Context Protocol, or anything related to the automation. I hope this session was helpful for you guys, and I hope you learned something new. I will share all the content on my website about the MCP, about the Asian mode, about the unit test. I didn't have the chance to present this today, but I want to thank again the global Azure team, and especially Massimo, for this opportunity to talk and share my knowledge with others. Massimo, I think you are here.
Yeah, back, Ashraf. Thank you so much for your session, sharing so many live demos. I love it. So
Thank
we
you.
are at the end of our event. Not only thank you, I want to thank everyone that participate, and also the people that will watch offline in the coming days these sessions. It was a great day online and also here in Ghent. It's time to say goodbye, and happy Azure to everyone.
Happy Azure to everyone, and thank you everyone for watching us. Thank you, Massimo. Hope to see you in another event.
With pleasure, Ashraf. Bye bye.
Bye bye.